Hi, this is Mr. Ward, and I'm doing a short tutorial on how you can use spreadsheets to get the standard deviation. So I have a piece of data that I collected of ages of fifth graders, and here they are. Nice little stack of data. They're nicely in order. And over here, we've got the standard deviation formula for a population or a sample. Well, probably can imagine that this is not all the fifth graders in the world, so that is not a population. That is a sample. It's probably not even all the fifth graders in a particular school, which could be a population that is defined as all fifth graders in a school. So this is a sample of fifth graders. So we're going to use this formula. So the standard deviation, we're going to need the square root of this thing here. So inside the parentheses, this X means the observed data, and this X with a bar over it means the mean of that observed data. Okay, so, and this little symbol here means that we're getting the sum of these differences, and we're actually getting the sum of the squares of these differences. So we get observation minus mean squared, and then we add up all of those squared observation minus mean. Now, observation minus the mean is the deviation. The square of that is called the squared deviation. And the sum of the squared deviation is what you need in this numerator. Then you're going to divide by n minus 1. The formal name of that is actually called the degrees of freedom, but really we're just taking one away from the total number of things in the sample. So we get the sum of squared deviations, divide it by the total number of things minus 1, and then we get the square root of that. Now that's a whole lot of stuff. Let's go ahead and have spreadsheets make it easy for us. So the first thing we need is we have our data. So that's our observations. That's X. Then we need the mean. So let's get the mean of that data. So we go down here to where I've said mean, and I say mean is average in this case in a spreadsheet. So equals average. And look, it's already trying to fill it in for us. So let's accept that. And there we have it. So the formula was average equals average, and then in parentheses, the range of the cells that we wanted. Cool. Now we've got the mean. Now take note that that is an A23. My next thing is to get the deviations. So the deviations are my observed data minus my mean. So I'm going to say equals observed data minus, and now I want A23, which is that data, that mean down at the bottom. Okay, I can do something to make my life a lot easier. I want to actually lock that cell down by putting a $sign in front of the A and a $sign in front of the 23, so that when I do that, I can hit enter and it suggests an autofill for me. And I could hit check and it'll fill all those cells. Now I'm going to actually hit X because I want to show you the other way to autofill. So I'm in this cell and you see this little blue square. If I double click that blue square, it autofills for me as well. Now, since I put $ symbol in front of A and 23 for A23, it preserves that cell while the cell we're subtracting from, notice it's changing. A2 becomes A3, becomes A4, becomes A5, and so on. So we're subtracting this observation minus the standard deviation, minus the mean. So observation minus the mean in every case. Now I don't need that and I don't need that, so I'm just going to make them go away. Now my next step is to square those deviations. To square something, we just say equals the thing we want to square. So I shift over and select that cell. And you see now I have equals B2. Then I hit Shift 6, which gets me that pointy hat thing, and 2. And what that means is equals B2 squared. So I hit enter. It's going to suggest an autofill. I will accept that. I don't need to worry about any kind of absolute cells or anything because I'm not making a reference to another cell. I'm just squaring whatever's the contents of that cell. Okay, my next thing I need is the sum of this set of squared deviations. To get a sum, I say equals sum in parentheses, and then I select all of these and enter. Okay, and we get rid of that. We don't need those zeros there, it doesn't matter. Now I want the variance. Now the variance is just going to be this divided by, if it was the whole population, it'd be divided by the number of things in the population. But since it's a sample, it's going to be divided by the number of things minus 1. So I could count them. There's 20 sets of data, and I could say 20 minus 1, or I can say, in parentheses, count, parentheses, and then I want to get a count of my data. So I select A2 to A21, in parentheses. Then I'm going to say minus 1 and in parentheses again. And what that does is say the count minus 1 is my denominator. By putting that parentheses out there, I know that I'm subtracting 1 from the count and making that my denominator. If I didn't have this parentheses here, I'd be doing D2, my variance, my sum of squared deviations, divided by my count, and then I'd subtract 1 from all of that, which I don't want to do. I want to have it be n minus 1 in the denominator. So I hit enter, and I've got my variance. Now, the square root of the variance is the standard deviation. So I'm going to say equals SQRT for square root. In parentheses, I select my variance, in parentheses, and I now have my standard deviation. 0.716. Now you get, if you didn't set the number of decimal places, you might end up with something like this, and so forth. Okay, so I'm going to, in this sheet, have a couple more sets of data for you to do this with, and I hope that has been helpful.